humans, I'm Mr. Khing. Hey yo people, welcome back, long time no see. Alright, now let's go into this past year paper 2021 October November paper 41. Alright, let's go. Okay, you see Q1, this is given here. Some elements K are shown in the order that they appear in reactivity series. Okay, so answer the questions using the list of the elements and blah 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 blah. So first one, identify a non-metal. So of the list above, which one is non-metals? Okay, very obvious. We know it is hydrogen. And the next, which one is a metal which is stored under the oil? Remember, okay, it has to be group 1 elements. Okay, let me see, how do we keep all the group 1 elements again? Let me see, we keep all the group 1 elements in the oil. Why? Because group 1 elements, they are highly reactive. So it's given here, the only group 1 is sodium. Next, the main component of steel. Remember, you see steel, it is made of iron. A metal with 3 electrons in the outer shell. See, 3 electrons means it is in group 3. So of all the elements here, so which one is in group 3? So answer it is aluminium. A metal found in brass. Let me see, so what are the composition in brass? Let me see, brass, it is an alloy that is made of zinc and copper. You see, both zinc and copper are in the list. So therefore, the answer, it can be zinc or copper, either one. Then next one, a metal that forms chloride of the type XCl2 and XCl3. Can you see? Okay, XCl2 and XCl3. So you see, from here we know that X contains 2 different charges, or so-called more than 1 oxidation state. So what types of elements that have more than 1 oxidation state? So in this case, we know it has to be transition element. So from the list, transition metal, so it would be iron. Alright, okay, next one. What is the main, name the main ores of zinc? Let's see, zinc compound, it is called zinc blende. Aluminium compound, it is called bauxite. That's it. Okay, next, in an experiment, a sample of aluminium appears to be less reactive than expected. So what is the reason why? Remember, okay, of all the metals, aluminium is the one and only metal that is always protected with this oxide layer. Okay, so there is this protective oxide layer. Okay, that acts as a barrier to prevent aluminium from coming in contact from other substances. Okay, next page. Name 2 metals from the list which are extracted by reductions of their ore using carbon. So you see, it can get extracted by reduction with carbon. So which means all these metals, it has to be less reactive than carbon. So you see, based on the list, let me see, where is the positions of carbon again? Let me see. In reactivity series, carbon is placed in between aluminium and zinc. Alright, so metals that are less reactive than carbon, we have zinc, iron, and copper. So any of these. So answer can be zinc, iron, or copper. Next. So when zinc granules are added to aqueous copper 2 sulfate, a reaction takes place. So during the reaction, a red-pink solid is formed and the solution becomes colorless. So name the red-pink solid. See, zinc, it is added into copper 2 sulfate. So what is this reaction? So this reaction, it is an example of displacement reaction. So you see, let's look into the equation. So zinc added into copper 2 sulfate. Zinc is more reactive than copper. So zinc displaces copper to form zinc sulfate and copper solid. So what is the red pink solid produced? May you see red pink solid or brown solid? Okay, in this case it is copper solid. Okay, displacement reaction is taken place. And then what is the colorless solution? So it would be zinc sulfate solution. Remember, okay, zinc. Okay, zinc metal solution is always colorless. How do we know? Remember, only transition metals can form color compound. Non-transition metals that form colorless solution. So next, in terms of particles, why the rate of the reaction increases when the temperature increases? 3 marks. So see, in terms of particles, so when temperature increases first, the kinetic energies of particles increases. So therefore, particles move faster. So which eventually the rate of collision increases. Okay, and lastly, therefore, particles that have sufficient energy to react. Okay, always remember to include this point. Okay, this is the point where students more often forget to include. Okay, so when particles move faster, rate of collision increases, so which eventually can generate more energy. So which eventually causes the particles to have sufficient energy to react. That's it. Easy 3 marks. Okay, and then you see 2 other ways to increase the rate of reaction. So what are the other factors that will also affect the rate of reaction again? Okay, we can add catalyst. What else? We can also use solution with greater concentration. Okay, what else? We can also use solid with smaller particle size. Okay, remember powder form is better. Why? Okay, because of the greater total surface area. Okay, so next one. Okay, Q2. So given with these 2 atoms, so state the term used for atoms of the same element with different neutrons number. You see, same element but with different nucleon numbers. So we know it is isotopes. Okay, then the numbers of proton, neutron, electrons. Let me see. Number at the top left hand corner, it is the mass number, okay, which is the sum of proton and neutron. Okay, and given here atomic number, let me see, atomic number is the same as proton number, which is 29. So proton number 29, neutrons, so 63 minus 29, you get 34. And then electron, you see there is no charge given here. So this atom is neutral. Okay, neutral atoms that have the same numbers of protons and electrons. Okay, next one, proton number 29, neutron 65 minus 29, eventually you get 36. And then you see the charge, 2 positive. So 2 positive means there are 2 extra protons compared to electrons. So since there are 2 extra protons, so electrons, it would be 27. Okay, next, given with this, relative atomic mass is the average mass of naturally occurring atoms of an element. So percentage is given here. So you're asked to deduce the relative atomic mass of copper in this sample and give your answer to 1 decimal place. So how to do for it? Alright, so you see, copper with a mass number 63, 70%. Copper with a mass numbers of 65, Okay, that is 30%. So what is the average mass? Alright, so we carry out the calculation. So the one we massed 63, 70% plus the one we massed 65 multiplied with 30%. We divide by 70 plus 30. Total percentage is 100. So divide by 100. Okay, so eventually you will have 4410 plus 1950 divided by 100. Eventually we'll get 63.6. Remember, okay, there is no unit for relative mass. Okay, no unit. Right, so this is how to look for it. So you look for the total mass, okay, based on the percentage, and then you divide by the total percentage. So this is how we look for the average mass. Okay, next one. Okay, given with this, see, anhydrous copper 2 sulfate is used to test for the presence of H2O. So when the test is positive, hydrated copper 2 sulfate is produced. So state the color change. Alright, so let me see. If you test anhydrous copper 2 sulfate with H2O, so the color changes is from white to blue. Remember, okay, the colors of anhydrous copper 2 sulfate is white in color. So when it is added with H2O, it forms hydrated copper 2 sulfate. Remember, you see, hydrated copper 2 sulfate. So in the presence of H2O, can we see copper 2 ions, it is blue in color. So this is the reason why it turns blue in color. Okay, the next one, balance the chemical equation. So CuSO, for example, to form a hydrated compound. So and with H2O balance it. So you see there are 5 H2O here. So we have to put 5. That's it. Okay, next. State how hydrated copper 2 sulfate can be turned back into anhydrous copper 2 sulfate. You see, clue is already given here. See, what does this stand for? Reversible reaction. You see, when it is added with H2O, it forms hydrated compound. So from hydrated back to anhydrous, let me see, anhydrous means compounds without water molecule. Alright, so how to remove the water molecule? So it can be done by heating. Okay, heat, and therefore all the water molecule will get removed or evaporated. Okay, next. Describe a test for pure water. So how do we test whether the water is pure or not? Let me see, we can check on the melting point, boiling point. Okay, pure substance that have sharp melting point and boiling point. So okay, test the melting point. And what's the melting point for H2O? Again, a pure H2O, okay? And it is 0 degrees Celsius. Or you can also say test for the boiling point, and it is 100 degrees Celsius. Okay, next one, you see, aqueous copper 2 sulfate contains Cu2 plus ions. So describe what is seen when aqueous copper 2 sulfate is added into sodium hydroxide solution. Alright, see, sodium hydroxide, it is added with solutions that contains copper 2 ions. Remember, so see, this is an example of cation test. So the copper 2 ions will react with sodium hydroxide to form copper 2 hydroxide, okay, with the observation of blue precipitates being formed, okay, because of the presence of copper 2 ions. Okay, next one, write the ionic equation for the reaction between aqueous copper 2 sulfate and aqueous sodium hydroxide. Okay, see, include the state symbol. Okay, remember, see, this is ionic equation. Okay, it's basically just write the chemical equation for the formation of precipitate. That's it. So we know that the precipitate is copper 2 hydroxide. So Cu2 plus aqueous plus hydroxide aqueous to form copper 2 hydroxide, which is solid. Okay, remember, balance the equation. Okay, you have to add 2 in front of the OH. And this is how it looks like. Okay, then next one, see the moles calculation. So first, let me see. Always list out the information that's given to you in the questions itself. Okay, because by doing so, it will give you a clearer picture of what formula to use. So this is given here, 4.7 grams of copper 2 nitrate is heated. So this one, 4.7 grams, and you're asked to look for the volumes of nitrogen dioxide. So first, what is the mass of 1 mole of copper 2 nitrate? Let me see. Mass of 1 mole, it is the same as the molar mass. Alright, so what is the molar mass? So you see, you can get the atomic mass of each element from the periodic table. So 1 Cu is 64, and then plus 2 nitrate. So 1 N is 14 plus 1 O is 16, there are 3 O, and everything here we have to multiply with 2 because you see bracket 2 and O3 1. So eventually, press on calculator, you will get 188. Okay, next one. Calculate the mass, calculate the numbers of moles of copper 2 nitrate used. So you see, now we have the MR, we have the M, which is 4.7 given here, and what is the numbers of mole? So in terms of mass, the formula is N equals to M over MR. So M 4.7 divided by MR 188. So eventually you will get 0.025 mole. Next one, determine the numbers of moles of nitrogen dioxide formed. So in this case, we can just compare the moles ratio. So for the moles of copper 2 nitrate and nitrogen dioxide. So what's the moles ratio? Ratio 2 to 4. So 2 to 4, if copper 2 nitrate is 0.025 moles, so therefore the moles of nitrogen dioxide gas, it would be 0.05 mole. So this is how to look for the answer. Okay, next one. Calculate the volumes of nitrogen dioxide formed at room temperature and pressure. See, volumes of gas. So with the formula, N equals to V divided by 24 dm cube. So numbers of mole, we have found it here, 0.05. So 0.05 equals to V divided by 24 dm cube. So eventually you get 1.2 dm cube. Okay, next. So write the chemical equation to show the actions of heat on sodium nitrate. See, this is thermal decomposition of sodium nitrate. Remember, okay, group 1, nitrate, like example, potassium, sodium, they undergo thermal decomposition to form metal nitride and oxygen. So it is NaNO2, sodium nitride and oxygen. Balance the equation 2, 2. So this is how it looks like. Okay, then next one, examples of electrolysis questions. So you see, chloride ions are discharged at the anode. So complete the ionic half equation for this reaction. See, chloride gas selected, so to form chlorine gas, okay, and balance equation, so 2, 2. So this is how it looks like. Okay, next, so state whether oxidation or reduction takes place. Explain. So you see, electrons is written on the right hand side. It means that electrons are given away. So you see, when electrons are being released, so this reaction is an example of oxidation. Okay, because electrons are released. Next one, what are the observations at cathode? So you see, before we go into this, isn't it? First, you need to know what are the ions that get selected to be discharged at anode and cathode. See, first, What are the ions present in this electrolyte? See, concentrated hydrochloric acid. So they are hydrogen, chloride, hydrogen, and hydroxide, aqueous solution. So it contains water molecule. Alright, so positive ions will always get attracted to cathode. Positive to anode. Negative ions, okay, remember negative ions get attracted to anode. Different charge they attract. So which one, okay, will get selected to be discharged at cathode? You see, cathode contains only hydrogen, so hydrogen will get selected to form hydrogen gas. So when hydrogen gas is produced, so observation, effervescent. And then followed by half equation, hydrogen gas selected by gaining electrons to form hydrogen gas. Balanced equation, so this is how it looks like. Okay, then next one. So suggest the pH of the electrolyte at the beginnings of the solution. Alright, so you see what is the pH at the beginning? You see, this is concentrated hydrochloric acid. So it is strong acid. Remember, you see, inorganic acid is an example of strong acid. And what is the pH values of strong acid? Okay, pH 1 to 3. So it can be either one. Remember, okay, do not put your answer in range. Next one, state how the pH changes, if at all, during the experiment. So how the pH changes? So you see, first, what ions will get selected? You see, hydrogen gets selected, and we know that anode chloride get selected. So see, the concentrations of hydrogen and chloride will decrease. You see, the main one is hydrogen ions. So when the concentrations of hydrogen ions decreases, what happens to the solution? It gets less acidic. Remember, the acidities of the solution is based on the concentrations of hydrogen ions. So therefore, the pH increases, okay, because hydrogen ions is being removed. So which eventually causes the concentrations of hydrogen ions to decrease and therefore gets less acidic. Okay, then next one, electrolysis is repeated using molten lead to bromide. See, molten, let me see, the difference between molten and aqueous is that in molten electrolyte there are no hydrogen and hydroxide. So the ions present is only lead-2 and bromide, that's it. So cathode attract positive ions. So lead-2 will get selected to be discharged at cathode. So you see lead solid is formed. So what is the observation? Solid is deposited. Anode attract negative ions. So you see bromide will get selected. So to form bromine gas. So observation, brown gas is produced. Remember again, you cannot put effervescent. Effervescent is only for colorless gas bubbles. Okay, next one. State two properties of graphite or carbon, okay, which makes it suitable for use as electrodes. So the very first reason, may see they are all examples of inert electrodes. So they are inert. And other than that, remember the functions of electrode is to conduct electricity, which means it has to be conductor. So graphite it is a good conductor of electricity. That's it for this electrolysis part. Okay, so next one. Okay. Organic chem. Okay, so given here, complete the chemical equations for the reaction. So given with this equation, so balance it. So you see it's mentioned here. Sulfur dioxide will be produced with iron 3 oxide and copper 2 oxide. So the products are sulfur dioxide Fe2O3 and CuO. Okay, and then next, okay, we have to balance the equation. So you see, left hand side there are how many sulfur? 4 multiplied with 2, you have 8. So make it 8 sulfur. And then now left hand side, okay, there are how many? So left hand side there are how many iron? 4 multiplied with 1, 4. Okay. So therefore, answer it is, you have to make it 4, isn't it? So we put 2. Okay, and then left hand side, how many copper? Okay, how many copper? 4 multiplied, we have 4, isn't it? So to make it 4, we put 4 over here. Okay. Alright, okay. Then next one, you see, given with this, you see, this reaction is exothermic. Okay, so state 2 features of an equilibrium. Let me see, what happens during equilibrium again? Okay, let me see, define the term. Okay, so first, during equilibrium, let me see, the rate of forward and backward reaction is the same. Okay, and then next one, concentration of reactants and products remains unchanged. Let me see, these are the 2 keywords that you have to include in the definitions of equilibriums. So next, state the temperature and pressure used in this reaction. You see, this is contact process. So the temperature needed 450 degrees Celsius and pressure is 1 to 2 atm. Okay, next one, catalyst in contact process, it is vanadium 5 oxide. Okay, and why a catalyst is being used again? See, the functions of catalyst is to speed up the rate of reaction. So next one, describe and explain in terms of equilibriums what happens when the temperature increases. So you see how temperature affects the positions of equilibriums again. Remember, okay, increase in temperature will always favor endothermic reaction. Alright, so it's given here. Forward reaction is exothermic. So means backward is endo. And increase in temperature favors endothermic reaction. So you see, in this case, endothermic reaction is backward reaction. So therefore, equilibriums would shift to the left, okay, because backward reaction is endothermic. That's it. Alright, so this is how temperature would affect the positions of equilibriums. Next one, concentrated sulfuric acid is a dehydrating agent. So when glucose is dehydrated, carbons and 1 other products are formed. So complete the equation to show the dehydration of glucose. You see, clue is given here, dehydration, which means water molecule is being removed. So you see, if one product is carbon, so the rest it has to be just HNO. So you see dehydration, so it has to be H2O. Alright, so balance equation, you see left hand side 6 carbon, so right hand side 6 carbon. So left hand side 12 hydrogen, to make it 12, it has to be 6 as well. Alright, so this is how it looks like. Okay, then next one, state the term used for a family of similar compound. So it is what I call homologous series. Then general formulas of alkane, CnH2n. Okay, next one, you see, addition reactions of butene, okay, with bromine. So what is the color changes again? Let me see. When it is tested with bromine liquid or aqueous bromine or bromine water, let me see, it is always orange in color and it turns colorless. Remember, okay, do not put brown. Okay, a better answer is always orange in color. All right, for the colors of bromine liquid. So next one, okay, what is meant by the term addition reaction? So during addition reaction, only one product is formed, addition reaction. And then write a chemical equation for the reaction between butene and bromine. So C4H8, chemical formula of butene added with bromine. So it forms C4H8 Br2, okay, addition reaction. Next one, butene forms a polymer. Suggest the names of the polymer formed from butene. See, when alkene form polymers, the names of the polymer, we just add the word poly right in front, we do, that's it. So it become polybutene, that's it. Okay, so next one, see, name and draw a structural isomers of butene. See, show all the bonds and everything. Okay, see, isomer. You see, what is isomer? Remember, see, isomer means compound with the same chemical formula but different structural formula, okay, which means different arrangement. See, butene means the double bond is placed between the second and the third carbon. So another arrangement, it would be but1ene. Okay, means the double bond is placed in between the first and the second carbon. So it looks something like this. So 4 carbon, remember, okay, 1 carbon is always surrounded with 4 single bond. Okay, then next one, given with this, you say carboxylic acid. So deduce the empirical formulas of butanoic acid. So you see first, what is the molecular formulas of this butanoic acid? So you can see how many carbon here. 1, 2, 3, 4. Okay, so 4 carbon and how many hydrogen? 8 and 2 oxygen. See, empirical formula simplify form. See, 4, 8, 2, they can get simplified by 2. So eventually you get C2H4O. Okay, so next one, complete the chemical equation for the reactions of butanoic acid and sodium carbonate. See, let me see. When it comes into the reactions of carboxylic acid, isn't it? Let me see. It is always the H in the COOH that will get released. So this H will get released and reacts with sodium. So the salt produced with the chemical formulas of CH3, CH2, CH2, COO, and A. So you see acid plus metal carbonate to form salt, water, and carbon dioxide. Okay, balance the equation 2. So this is how it looks like. Okay, next one, I see formations of ester. Butanoic acid reacts with methanol to form an organic compound called ester and H2O. So what is the organic compound called? Let me see, when it comes into the word formulas of ester, we start naming with the alcohol part. See, methanol should become methyl and then followed by acid, butanoate. And how do you draw this? Always start with the functional group first. COO. Remember, you see, after the O, it belongs to the alcohol part. See, alcohol, there are how many carbon over here? Methyl means 1 carbon. So add 1 carbon and the rest hydrogen. Acid part total, how many carbon? See, butanoate total 4 carbon. So 1 carbon here. So second, third, and fourth. And then the rest, they are all hydrogen. Ta-da! So this is how it looks like. Alright, so far so good. So if there's any questions, you guys can always drop a comment, okay, and ask. Alright, then that's all for this paper. Thanks for watching. Thanks. Remember to like the video and subscribe to the channel. See you again. Bye.